My favorite thing about being an engineer is going to the field. And in this video, we're going to go to a chilled water plant on a university campus. Aside from just walking around and seeing everything, I wanted to tie the equipment and the instrumentation back to the building automation system. The building automation system is where you have the opportunity to control the performance of the equipment and make it energy efficient. My name is Jane Geyer, and I'm a principal engineer at the ETC group. And I would like to thank the University of Utah for allowing me into the plant all alone during COVID to film this movie for the purpose of education. We're standing in the Southwest Chiller Plant at the University of Utah. It's one of 3 chill water plants that serves the campus. This particular plant serves about 2 million square feet of building on campus. It's a 4,000 ton capacity chill water plant located in the field house, which is a building that you would go to lift weights if you went to the U in the 90s. But now it's been renovated to the chill water plant, and that's the cooling tower sitting outside. And this is the area that this plant supplies, so pretty big piece of campus. In the plant, there's chillers that are covered. And one of the things we like about going to the field is that we can get information off the control panels in the field that is often more revealing than what we can get from a building automation system. This control panel on the chiller tells us that the chiller that we heard running is running at 84 kW. So we can correlate that power to outside air temperature and understand the load of the plant. On the other side of the plant, the primary pumps, which are responsible for pumping chill water through the chillers, are on the ground floor. The secondary pumps are up on the mezzanine. These are the pumps that pump the water through the loop all across that big area of campus that I showed you. Pumps are all controlled by a VFD. And the other thing we like about being in the field is we can readily read what speed those pumps are running at. These pumps are running about half speed. And not all pumps are created equal. These are vertical turbine pumps, and this is a condenser water side of the chiller plant. And these are drawing water out of the sump that we are standing on top of. And you can see that those pumps have VFDs in the background and the electrical panels on the wall. And then finally, the chiller, there are 2 compressors on the chiller. So the first compressor on top is and looking at the chiller from above, the compressors are VFD compressors, and this is the condenser bundle that the shell and tube heat exchanger. Can't see the evaporator bundle in this particular view, but there's more information on how the chiller refrigerant circuit works in the full video. And this 3-way valve is used to divert water away from the chiller to a flat plate heat exchanger under conditions where it's cold enough outside that the cooling tower can make cold enough water to heat exchange and make chill water for the building. So we call this free cooling. It's a energy efficiency feature of a chill water plant. And there's the outside view of the cooling towers, 2 cells with the fans on the top of the cells that we saw in the plan view. And finally, the thing that I really like to do, and what I like about going to the field, is you can see the instrumentation that you're actually viewing then on the building automation system. So this is a screenshot from the building automation system. It shows us all of the live temperatures, all of the flows at the bottom here. Actually, there's the pumps we saw, primary and secondary pumps. There's a flow meter, I'll show you in a second. And then there's 2 temperatures read across the supply and return. So those 2 temperatures and that flow gives us the entire cooling load this plant is generating. And so we go back to the field, there's the flow meter. And on those 2 pipes down below, there's a temperature sensor in each pipe. And so those readings are brought into this BTU meter, and that's how we can see the whole load of the plant. And with that information, you can efficiently stage the equipment in the plant. That's it for our shorty. If you'd like the long view, the link is at the end of the show.